Hello, everybody, and welcome back to the next episode. In this episode, we are gonna explore how we can do a polygon versus polygon collision detection. This will be purely theoretic, and yeah, I'm just gonna guide you through what we are gonna do in the next episode. Well, what we're gonna code in the next episode. So let's jump right into this. We will have three methods. One method is the polygon versus polygon method. This will return a manifold or a contact point. Well, it's a manifold which holds all the information about the collision. And based on this collision manifold, which we implemented earlier, we can do the collision resolution. The next method, get contact point. This method actually is searching for a contact point, the best point we can get. And yeah, I'm going to show you how we can, or how we, what we're going to do in this method. And then the last one is the find support point method. This also searches for a best point and the best normal, and with this point, with the best point, we will it's going to return the best point to the get contact point, and this will return the best point to the polygon versus polygon method, and with this point we will resolve the collision then. Okay, so as I said, the method we're going to call is polygon versus polygon. In this method, we will have two calls, two get contact point calls with these two methods. So basically, we will search for a contact point which is intersecting with the orange one. In this case, it will be like the blue one. This will be this one, and then we call the get contact point on the other shape, and this will be the orange one in this case. So we are only calling 2 times the get contact point in the polygon versus polygon method, and we return the best contact point. In this case, the best contact point is the one with the biggest depth, and this is this point. If you compare these 2 points, note that this dotted line is perpendicular to the orange line. So this one is perpendicular, and this orange line is perpendicular to the blue line, okay? And in this case, the best contact point, if we compare these two, the best one will be this one, because this one has the, let's say, deepest depth. Yeah, that's basically the get contact point. The polygon versus polygon method, sorry. And in the get contact point, we are searching for, we're searching for the best contact point on one shape. And this will be done. We will iterate basically on every normal. And we're going to search here for the best contact point. And I guess the best contact point is the one with a minimum penetration. So the lowest penetration, basically. I'm going to show what we're going to do here. So basically, right. One thing to note is that we will use the dot product. You can see here all the dotted lines are perpendicular to the orange ones. Okay. And basically having, they're just perpendicular to these lines. And we are iterating through every normal we have. We're gonna call the find support point method. This will be iteration 0. We will have, in this case, we will have 2 iterations. Sorry, 3 iterations for every, for every edge. I call this one the edge of each polygon. And for each edge, basically, we will call the find support point method. And in this case, with vertices 0, normal 0, so we call the find support point method. This will be in this section, and this we're gonna use this one for every normal, basically. Okay. Then the find support point method. In this method, we will search, or we will get the support point back, and we're doing this by projecting, well, we're making a direction vector from the vertice. I'm gonna call this point on edge. So basically that means the point is lying on the edge here on this line. That's why point on edge. And then we have normal on edge. And yeah, this is the normal for this edge basically. Okay. And for this case, we're making a direction vector from the point on edge, or from the vertices, from the second with the index of second, with the index of 2, and we're gonna create a direction vector to the other polygon vertice. Then we're gonna calculate the depth. This we are gonna do this with the dot product. I'm gonna show you this here. We can calculate this like this. This green line, the depth, is, well, it's basically the direction vector. This is this one. And then we're gonna take the dot product for the normals, in this case with the index of 2, because this is the normal for this edge. And yeah, we're gonna do this one with every other vertice from the other shape. For this one, and for this one. And here we're gonna return the point and the normal with the largest depth value. In this case, this will be this one. Yeah, and that's basically it. The challenge for the find support point method will be to basically to get the right point and the right normal, and comparing the largest value with the current largest value. This is a bit let's say, brain fuck, but I think we're gonna get around that pretty easy. Okay, yeah, that's for the find support point method. That's basically it. And we're gonna, here we're gonna find the best support point we will get back. Then we will return this support point back to the get contact point. Here we're gonna compare which support point has the minimum, or the best minimum penetration depth. And when we found the best contact point, we return this contact point to the polygon versus polygon, and then we compare this contact point with the same iteration but for the blue shape. So we did this one for the orange shape, and in the polygon versus polygon we're also going to do this for the blue shape. And that's basically it. I'm gonna show you how we can calculate this in the next episode. All right, then see you there and have a nice day.